Yes, these are the slides that Paolo Scalmani prepared, but he's not really willing to come up and present them, so I'm here. Basically, but I already presented you something in my presentation earlier. This is a story about the homeostatic response in the NEB 1.1 knockout mice model of Dravet syndrome. So here you have several papers have already shown it hypoexcitability of different subclasses of neurons, and we found the same thing. For example, in parvalbumin positive interneurons and these OLM interneurons that are somatostatin positive. So this is not. We haven't found the same thing in cholecystokinin positive basket cells that show hyperexcitability. This is a quantification of the hyperexcitability. If you quantify the action potential, number of action potentials as a function of the depolarizing current injection, there is no difference. But then there is a difference in amplitude of the action potentials, in the shape of the action potentials that are higher, with a higher slope. And then there is a difference in action potential failure. That means, I won't explain it in detail, that means that you, in general, when you have a train of stimulation, you get more action potentials for the CCK neurons in the knockout mice than in the wild type. So there is less failure in action potential generation. So we interpret it as an homeostatic response. We think that it's not just an increase in GABAergic synaptic transmission, because cholecystokinin, as I said, is a peptide that is co-released with GABA at the synapses of these neurons. And I don't know what Paolo wrote here, but anyway, this peptide can increase the excitability of other interneurons like parvalbumin positive GABAergic neurons. And so we crossed our Dravet syndrome mice with CCK knockout mice. If the hypothesis, if our hypothesis is correct, we should get a worsening of the phenotype. And this is what we got, as I showed it already. So just to say that there are a lot of different subtypes of neurons. For example, also this somatostatin GABAergic neurons can co-release a peptide that is somatostatin with GABA. There are other interneurons that release other peptides. That these are probably responses that we should study to have the overall picture of the effect of the mutation.